Hi everyone, this is Sangeeta working as Assistant Professor in IoT department. This session we're going to discuss about address resolution protocol, which is important protocol because if you want to identify a host, means we need three kind of addresses. Last class I said, right? So for that, if the router or the device, if we have only IP address, if you want to send a messages to the host, so with the help of the IP address alone, we cannot send it. So for that, we have to find the corresponding physical address of the host to deliver it. So it actually processed by address resolution protocol and the reverse address resolution protocol. Both the protocols plays a vital role to identify the corresponding MAC of the host and also the IP address of the host. It works between a data link layer and network layer. Okay. So here, this session, we discussed about ARP mean. So ARP is address resolution protocol. So it's the most important protocol which is worked in data link layer. So ARP is a network layer is to convert the IP address to the MAC address. So MAC address, we know that it's a physical address, or we can say Ethernet address. It is a 48-bit address. IP address, normally we use version 4, it is a 32-bit address. So the ARP actually works between data link layer and network layer. So it have the input of logical address. With the help of that logical address, it's usually used to find the physical address of the particular corresponding IP. So here, consider the scenario. So the purpose of AAP address resolution protocol is to convert the 32-bit logical address to the corresponding physical address. This protocol works between 2 and 3 of the leg. And that if it is 2 means it works in the data link layer. If it is IP address resides, it works in the network layer. So normally how it works means if the one particular host or router is there, if you want to know the IP address of the particular, physical address of the particular IP, it broadcasts a message that will send to the all other node of the network. So request message will be sent to the all other node of the network. It having the message like I'm looking for a physical address for the corresponding IP address. Likewise, the message is broadcasted to the connected devices in the network. When the corresponding IP address of the particular node received that request message, it immediately replies to that request with an physical address. So actually, what it actually do means when the request is arise, it broadcasts a message to all the connected node who's having a MAC address of the corresponding IP. If the particular node receives a request message and it check with that IP, if it is matched, it immediately respond with an corresponding physical address. So likewise, the ARP will get back the MAC of the particular IP. Okay. So here, type of mapping in IP address, IRP will use like static mapping and dynamic mapping is used. Static mapping, a table consists of logical address and also the corresponding physical address. So you have a database which have both physical and logical address. So in this site, when the packet arrives, check what that IP and MAC of the particular device is entered manually in the ARP table. In dynamic mapping, if a device, the logical address of the other device, by using ARP protocol, if the device is find the physical address of the corresponding IP. So the dynamic entry is also created automatically when the sources send a broadcast message like a request message. Okay. So then ARP table. The problem encountered while mapping local routing may be summarized. So actually, normally these are the problems can be addressed. Like how does host A know whether host B is in the same subnet? That to not known. Then how does whether the host A obtain MAC address of the host B, whether it's correctly received or not? These things are the challenges in ARP table. So ARP table works like this: is to have a cache memory, IP address, and corresponding MAC address will be stored. And whenever the request is received, it will send a broadcast message to that on the node. Whether check with that database, if it is matched, it immediately respond with that ARP reply. If not, the message will be discarded. Likewise, the routing table, ARP table will be used. So next. ARP types, there are several address accession protocol types are there. One is proxy ARP, then gratitude ARP, and third reverse ARP. Other piece, reverse ARP means physical address to IP address, vice versa. Then inverse ARP. These are the different ARP types are used. In the proxy ARP, the ARP actually act as a on behalf of a set of host. Whenever the router running on proxy ARP receives an ARP request looking for an IP of the particular host, the router send an ARP reply announcing with a physical address. So it's working as a proxy for that host. Then gratuitous ARP method is used layer 3. So target is then different network from sender. The proxy ARP configured, router respond to the ARP and map the MAC address. But in the backend, the proxy router send it to the packet containing the necessary information. So in the gratuitous ARP is used to update the ARP table of other devices also. Then reverse ARP is used to find the corresponding logical address of the given physical address, and other inverse ARP it works like an you send a request and the reply message will be in the form of IP. So when one node is there receiving that, it will automatically forward through the corresponding requested node. It is used to find IP address of the node of the data link layer address. Then ARP packet format have hardware type and protocol type, which is used to find which type of hardware and also the protocol type. The remaining field is for header knowing sender hardware device address and receiver hardware device address and target hardware address and also the protocol address. These things will be added in ARP protocol. Okay. The next, so ARP protocol is mainly used to find the MAC of the given IP. The reverse ARP is mainly used to find the IP of the given MAC. So both working for address conversion in both the data link layer and network layer. So these two are important one for finding the corresponding MAC and IP. Okay. The next session we will discuss different cases included for ARP examples. Okay. So this session what we discussed about ARP and ARP, how it works, how it broadcasts a message to all other node and how it responds, it receives the responses and how it works actually. There are several types of the ARPs are there. Mainly ARP and reverse ARP will be used to find that. Then the header format having hardware and protocol type of the source and destination. Okay. Next session, we will discuss the other real-time cases of this ARP protocol. Okay. Thank you so much.